Welcome to the Before AGI podcast. Today we're doing a deep dive into something, well, really important at the crossroads of AI and the planet, its environmental impact.
That's right.
And for you listening, especially if you're keen on understanding AI deeply, this is critical. It's about the tech, sure, but also its real-world consequences.
Exactly. We've got some pretty eye-opening research to unpack. It covers the challenges, the energy demands, the resource use.
But also the positive side, the innovations.
Oh, yeah. Solutions, too. We want to give you the key insights, the main challenges, and, where things might be heading.
Okay, great. So let's jump right in. The big headline seems to be AI's energy consumption. It's just growing incredibly fast.
It really is. The International Energy Agency, the IEA, they're projecting that global electricity demand from data centers could more than double by 2030.
Double. Wow.
Yeah, and they explicitly point to AI as the main driver for that. They're talking numbers like maybe 945 terawatt hours by 2030, potentially even 1,200 by 2035.
1,200 terawatt hours. Can you put that into perspective?
Well, 1,200 TWh is roughly the entire annual electricity use of Japan.
Okay, that's massive.
And that's just one forecast. Goldman Sachs, they're actually predicting an even steeper rise, like a 165% increase by the end of 2030 compared to just last year.
So where are we now? What's the current usage?
Right now, 2024, data centers globally are using around 1.5% of the world's electricity. That's about 415 TWh.
And who's using the most?
The U.S. is the biggest chunk, around 45%, then China at about 25%, and Europe around 15%.
And I guess the big environmental worry here connects directly to where that electricity comes from, right?
Precisely. If a large portion is still fossil fuel-based, which it often is, then this huge jump in demand means a serious increase in carbon emissions. Simple as that.
Okay, so let's break down how AI uses this energy. People talk a lot about training these huge models.
Yeah, training is definitely intense. Take GPT-3, training it just once apparently used something like 1.2, maybe 1.3 million kilowatt hours.
That sounds like a lot.
It is. And GPT-4, some estimations suggest it might be potentially 50 times more energy hungry than that.
50 times? Wow.
And the carbon footprint for training some models, well, reports have compared it to nearly 5 times the lifetime emissions of an average American car. Just for the training.
Okay, that's significant. But is training the whole story?
Actually, no. And this is kind of the interesting shift. The ongoing use of these models, what we call inference, that's now the bigger energy hog.
Really? More than the training?
Yeah, estimates put inference at maybe 60 to 70% of the total AI energy pie now. Training is more like 20-40%. It's just because AI is being used everywhere, constantly.
So billions of small queries adding up.
Exactly. Think about it. A single interaction with ChatGPT, for instance, might use roughly 10 times the electricity of a standard Google search.
10 times. Oh.
Now imagine if all Google searches suddenly use that kind of AI. The extra electricity needed per year could be similar to what the entire country of Ireland uses annually.
Ireland's total consumption.
Yeah.
Just from search. That really hammers home the scale.
It does, and you see it in the operational costs, too. Running ChatGPT is estimated to cost over $700,000 a day. That's largely energy costs.
Which hints that the environmental impact isn't just carbon from energy, right?
Yeah.
There's more to it.
Absolutely. Let's talk water. Data centers need a ton of water for cooling.
Right, keeping all that hardware from melting down.
Pretty much. Even a small, 1 megawatt data center can guzzle up to 26 million liters of water a year.
Okay, 26 million liters. Hard to picture.
Think of it this way. That's about the same amount of water as maybe 62 average U.S. families use in a whole year.
Gotcha.
And Google, just Google's data centers, used about 5 billion gallons in 2022. That's nearly 19 billion liters.
5 billion gallons. And globally.
Projections are scary. Global AI-related water use could soar to maybe 6 times Denmark's total annual usage by 2027. That's a huge strain, especially in water-stressed areas.
Wow. Okay, so energy, water. What else?
Electronic waste, e-waste. This is another growing problem.
Because the hardware gets outdated so quickly.
Exactly. AI hardware advances are so rapid that the lifespan of these specialized GPUs or TPUs might only be, 2 to 5 years? So projections suggest this could increase global e-waste by maybe 3%, maybe even up to 12% by 2030. That's like an extra 2.5 million metric tons of discarded electronics every year.
And producing that hardware in the first place has an impact too, I assume.
Oh, absolutely. You need critical minerals, rare earth elements. Getting those out of the ground often involves allows mining practices that aren't exactly sustainable, resource depletion, ecological damage. It's all part of the chain.
Okay, so the picture has some serious challenges. Energy, water, e-waste, resources. It sounds pretty daunting. But what's being done? Are we seeing innovation to make AI more efficient?
Yes, definitely. This is where things get more optimistic, I think. There's a lot happening on the innovation front.
Like what?
Well, a big area is algorithms, making the software itself smarter and leaner. Techniques like model pruning.
Pruning, like trimming a tree.
Sort of. You basically remove unnecessary connections or parameters in the AI model, making it smaller and faster without losing much accuracy.
Okay.
Then there's quantization. That involves using numbers with lower precision, which means less computation, and knowledge distillation, training a smaller student model to copy a bigger teacher model.
Interesting. I also read something about an Elmo algorithm, replacing complex math with simpler stuff.
Ah, yeah, Elmo. That's clever. Multiplication is computationally more expensive, more energy intensive than addition. So Elmo cleverly rearranges some calculations to rely much more on addition.
And the energy savings.
Can be huge, up to 95% for certain operations, apparently. It's these kinds of fundamental algorithmic shifts that can make a real difference.
That's impressive. What about the overall structure, the architecture of these models?
Also key. MIT developed something called a once-for-all network. You train one big, adaptable network, and then you can easily create smaller, specialized versions for different devices without full retraining.
And the benefit?
They estimated it could cut the carbon emissions from training a computer vision model by a factor of 1,300 compared to some other methods.
1,300 times less. That's incredible.
It really is. And then, of course, there's the hardware itself.
Right, the chips.
We've moved towards specialized AI accelerators, GPUs, TPUs from Google, others too. They're just much better suited for AI calculations than traditional CPUs, much more energy efficient for those tasks.
How much better?
Well, for specific tasks, things like edge TPUs designed for devices outside data centers can be maybe 5 times more energy efficient than even GPUs.
And looking further ahead, any radical hardware changes coming?
Neuromorphic computing is a big one people are watching. It's inspired by the human brain's structure and efficiency. The promise there is significantly lower power consumption.
Brain-inspired chips.
Yeah.
That's cool.
Plus, there's ongoing work on just generally lower power AI chips for edge devices and more efficient processor designs overall.
So it's algorithms, architectures, hardware, anything else? How we run the models?
Yes, definitely. Optimization matters. Even the choice of software framework, like TensorFlow or PyTorch, can have an impact. Converting models to standard formats like ONNX can help too.
And how you train them?
Absolutely. Smarter training strategies are crucial. Things like optimizing the hyperparameters, the settings you use for training can speed things up.
Yeah.
Transfer learning.
That's reusing knowledge from models trained on other tasks.
Exactly. Saves starting from scratch. Also, dynamic workload management may be running the really heavy training jobs when the grid electricity is greener or cheaper.
Makes sense.
And even simpler things, using smaller, more focused data sets if possible, or choosing AI model types that are inherently smaller and less complex to begin with.
So it's really a whole ecosystem of efficiency improvement.
Precisely. Attacking the problem from, pretty much every angle in the AI lifecycle.
Okay, so the tech is evolving. What about rules and regulations? Are governments starting to pay attention to AI's environmental footprint?
They are, yes. There's growing recognition, especially, I'd say, in the EU and the US.
What's happening in the EU?
Well, their big AI Act includes requirements for providers of what they call general-purpose AI models. Think the big foundation models to actually document their energy consumption.
The transparency.
Right. And models that are deemed systemic risks, which can partly be judged by their resource use, including energy, they'll face stricter rules. They're also talking about using regulatory sandboxes to test AI specifically for environmental protection benefits.
Sounds quite proactive. What about the U.S.?
In the U.S., there's a proposed bill, the Artificial Intelligence Environmental Impacts Act of 2024. The main goal seems to be first studying and standardizing how to even measure and report AI's environmental effects.
So measurement first.
Yeah, and it suggests a voluntary reporting system for developers, so maybe a slightly lighter touch initially, focused on getting the metrics right.
And globally, is there any consensus on this being an ethical issue?
Oh, definitely. Over 190 countries have signed on to various non-binding ethical AI guidelines, and many of those explicitly mention environmental sustainability as a key principle.
So the awareness is there, even if concrete laws are still developing.
Exactly. It signals a widespread understanding that this is an important dimension to consider.
Okay, now we've talked a lot about the costs of AI, but you mentioned earlier AI could also be a tool for sustainability.
Yes, absolutely. This is the crucial flip side. AI's power in analysis and prediction can be a massive help in making other sectors greener.
Like how? Give me some examples.
Okay, think smarter energy grids. AI can forecast demand much more accurately, helping integrate renewables. Or optimizing energy use in heavy industry, like cement manufacturing, which is notoriously energy intensive. Even things like better predicting household energy needs or making data center cooling itself more efficient. Google DeepMind famously used AI to cut cooling energy in their data centers by up to 40%.
Using AI to cool the AI, clever.
Right. And are we seeing this translate into real-world results?
Yeah. Are there actual successes out there?
For sure. AI-driven building management systems are already reducing heating and cooling energy. In the energy sector, predictive maintenance using AI helps prevent outages and optimize operations. Even power grid inspections are becoming more efficient with AI analyzing drone footage, for example.
So it's not just theoretical potential, it's actually happening.
It is. These are concrete ways AI's ability to crunch data and spot patterns is being used to tackle environmental challenges.
Okay, so we've covered a lot of ground. The huge energy and resource demands, the e-waste, the water, but also the really exciting innovations in efficiency, the policy beginning to take shape, and this potential for AI to actually help build a greener future.
It's definitely complex. AI offers so much, but that environmental footprint needs serious, ongoing attention and action.
From the algorithms to the hardware, the regulations, it seems the journey towards a more sustainable AI is underway. And for you listening, understanding these different facets feels increasingly important.
Yeah, it really highlights that we need to think about AI not just in terms of what it can do, but also its total impact on the world around us.
It really boils down to that balancing act, doesn't it? How do we keep innovating responsibly?
That's the core question, I think, for developers, for policymakers, and, well, for all of us trying to navigate this technology's rise. It's something to keep thinking about.
Definitely food for thought. For more deep dives into AI concepts like this, be sure to subscribe to the Before AGI podcast. And, hey, check out my YouTube channel too, Ian Ochieng AI, that's Ochieng, for tutorials and other insights.
Yeah, definitely check that out.
And let us know what you think. What other areas of AI's impact are you curious about? Maybe that'll be our next deep dive.